Hey guys, today we're going to talk about algebraic proof. I've already got my notes handout taped down into my binder. You can see that I just cut off the borders all the way around it and just taped it straight down. So you're going to want to do that real quick before you get started, and that way you have it all done. So pause the video and then come back as soon as you've got that done. Alright, we're talking about algebraic proof. It's the very first proof that you will do this year, of many. We will do lots of proofs. But we start with algebra because you're very familiar with algebra. You just came off an algebra class, and so algebraic proof just flows nicely with what you've been doing. So when you do a proof, you're basically justifying everything that you do. You are making a justification. You are telling why something is true. And so you make a statement and then you tell why. It's just like if you were with your mom and you're trying to convince her that you need $20 and you're trying to convince her. You can't just walk up to her and say, hey, I need $20. You gotta give her a reason. And so that's what proofs are. So as we're going through the proof process, just keep in mind that you always have to have a reason or a justification for everything or every reason that you, or every step that you come up with. So we're going to work on some reasons right now. These are algebraic reasons that you will use in your proofs. These should be very familiar. You've used them a lot in algebra, however, you probably never actually wrote them out. So we're going to write them all out. This is all based on the solving process of an algebra equation, mainly a linear equation. So the first one is the addition property of equality. We use that a lot when we're solving equations. It says that if A equals B, then A plus C equals B plus C. That statement, that if-then statement, gives you reasoning to add C, or add the same thing to both sides of the equation. As long as the equation starts out equal, then the addition property of equality says that it will continue to be equal as long as we add only the same thing to both sides, in this case C. Of course, that works for the subtraction property of equality. We can subtract the same thing from both sides. We can multiply the same thing on both sides, and we can divide by the same thing on both sides. So I'm going to pause the video real quick, and I'm going to fill all of that in up through division, and then come back, and you may have to pause it also, and that way you can get it all filled in. Alright, so I've got it all filled in now, and what I want you to do is pause the video, and I want you to write all of these down, 1 through 4, and then start the video back up again and let me explain those. Pause the video now. Alright, you're back, and so let's just go through these real quick. This one, of course, is the subtraction property of equality. If A equals B, then we have A minus C is the same thing as B minus C, which basically means we could subtract C on both sides of the equation and it's still equal. If A equals B, then we can multiply by C on both sides of the equation and it remained equal. So anytime we multiply by a number on both sides, that is the multiplication property of equality. And then last but certainly not least, the division property of equality that says we can divide by C on both sides. The equation remains equal. Now, you do have one qualification here, that C cannot be 0. As you recall from in the past, you cannot have 0 on the bottom of your fraction. It is undefined. Your calculator will freak out if you try to divide things into 0 groups. Alright, if you take a number, like let's say 10, and we divide into 0 groups, then that's going to be a problem. So you've got 10 of something, and you've got to put them into some groups, so you cannot divide a number by 0. So we just add this little qualification here, so that way you know that C cannot be 0. Alright, let's move on. The reflexive property of equality says for any real number any real number A, this is going to seem like a no-brainer. For any real number A, we know that A is equal to itself. A. Yes, I know it's true. You're sitting here thinking, why is she telling me that? Well, that's the reflexive property. The next one, symmetric property. If A equals B, then you know that B must equal A. Yes, that's it. I know, seems like a no-brainer, and you probably are going, well, duh. But that's what the symmetric property says. Basically what that means is if I get down to the end of my equation and it says x equals 2, but my neighbor gets down to the bottom of his equation and his says 2 equals x, it doesn't matter. We're both right. It's fine. Teacher's going to take it. Okay, thanks to the symmetric property of equality. All right, the transitive property of equality is one of my favorites. If A equals B and B equals C, then we know that A must equal C. If A equals B and B equals C, then A has to equal C. That's the transitive property. All right, substitution property of equality we will probably use a lot. We know that if A is equal to B, then A can be substituted for B in any equation or expression. Kind of ran out of room there. If A is equal to B, then A can be substituted for B in any equation or expression. In other words, if x equals 4, then wherever I see an x, I can put in a 4. All right? That's substitution. We do that all the time. Distributive property. Distributive property is basically this. If you have a number multiplied times a sum, then you can do what's in parentheses first and then multiply by A, or you can take and distribute that A times B, and then add A times C, and you can get your answer that way. So that's distributive property. All right, so what we're going to do here is we're going to go through each one of these statements, and we're going to talk about them and see if we can figure out which one they are. So if you want, you can pause the video and go through each one of these and see if you can figure out the answers for each one of them. And then start the video back up and I'll tell you which one's which. All right, the first one. Measure of angle 1 is 30, measure of angle 1 is measure of angle 2, so the measure of angle 2 must be 30. If you wrote transitive property, you did good. Okay, that is the transitive property. Second one, if 7x equals 28, then x equals 4. Well, what do we have to do on both sides here? Divide by 7 on both sides. So that was the division property of equality. This is kind of how I write that out, just to kind of cheat a little. Just put of equals. Division property of equality. If RS is equal to TU and TU is equal to YP, then RS must be YP. That's transitive again. The transitive property. Now the next one, if the measure of angle 1 is equal to 30 and the measure of angle 1 equals the measure of angle 2, the measure of angle 2 is, oh, that looks like a mistake. This one right here is exactly the same as this one up here. Let's change it. Scratch that one. Let's change that to if 4x minus 5 equals x plus 12, then 4x equals x plus 17, period. So if I'm looking at this equation, erase that a little bit, cross that out better. If I look at this equation and I can see that the 5 is missing, looks like we probably added 5 to both sides. So that's going to be the addition property of equality that went from here from this step to this step. We applied the addition property of equality. Now the next one, if 80 is equal to the measure of angle A, then the measure of angle A is 80. That is classic symmetric property right here. Just flip-flopping things around. Symmetric property of equality. Alright, so let's go through some example problems. Let's do our first one. The first one, the given information for you is 8x minus 5 equals 2x plus 1. Alright, we just write that that's given to us. And we're going to go through this equation, we're going to go through this equation step by step and giving the reasons for each one. So what you write down might be different than what somebody else writes down, and that's okay because there's multiple ways to do this. But let's say we wanted to add 5 to both sides. So that's going to give me 2x plus 6. And I write my reasoning is the addition property of equality. Number 3. Next thing I want to do is subtract 2x from both sides. So I have 6x equals 6. That is the subtraction property of equality. And number 4, divide both sides by 6. So x equals 1. And that is the division property of equality. Now when we get to the very end of a proof, I like to put the little 3 dots just to kind of show that that is the answer and that you're done. It's a therefore symbol. So this is this is this, therefore this is true. And that's why we do that. So you can add that to it. Alright, I got a couple more problems here I want you to try. The first one is 5 times x plus 7 equals negative 3. And then the next one down here is 6x plus 7 equals 8x minus 5. And then the last one that I want you to try is number 1, x plus 10 equals 2x minus 90. Now, I want you to be ready for the quick quiz, the Q squared. I want you to be ready to solve one of these statements and give reasons. So on the quiz, what I'm going to say is I want you to solve this, and I want you to do it as a proof. Solve this equation. So you'll give me the statements, and right next to it, you'll give me the reasons. So let me see here. Let's see, number 2, let's go ahead and write these answers here. Why don't you pause the video and work these 3 problems, and then we'll start the video back up here in a second, and I'll give you the answers. And you can check your work. Alright, here we are. I just want to double check to make sure that you got all your answers correct. Now this one right here is probably going to be very similar to what you did, but these 2 might be a little different. Alright, you're going to have to check yours, kind of trust yourself, and then you can look at mine if you want, obviously, to check and see how you did, but these might be a little bit different. Alright, so then what I want you to do when you come in is I want you to be prepared to do one of these on the quiz. Alright? You have a great, wonderful, fabulous day.